Hello, we would like to introduce our work, Pose-Adapted Shape Learning for Large Pose Face Reenactment. Unlike most face reenactments that focus on limited poses, our Pose-Adapted Shape Learning, or PASL for short, works for full pose reenactment. Full pose refers to the head's orientation changing from 90 degrees to -90 degrees in yaw. The motivation for this work is that most face reenactment works cannot handle large pose transformation because the facial identity cannot be preserved over a large pose variation. The poor facial identity preservation is primarily caused by the face encoder trained on pose-imbalanced datasets. To tackle this issue, we propose the pose-adapted face encoders, abbreviated as PAE, which consist of 6 encoders, and each encodes faces of a specific set of pose pairs between the source and reference faces. In addition to the pose-adapted face encoders, our model has 2 major modules, the cycle-consistent shape generator, CSG, and the attention-embedded generator, AEG. Given a source face and a reference face as inputs, the CSG generates a shapecode that fuses the source identity and reference action in the shape space and meets the cycle consistency requirement. Taking the shapecode and the source as inputs, the AEG learns the self-attention within the shapecode and cross-attention between the shapecode and source style to enhance the generation of the desired face. Due to the fact that current benchmark datasets are inappropriate for the evaluation of large pose face reenactment, we propose a scheme to select large pose face pairs and construct the MPIE-LP, large pose, and Vox Celeb 2 LP subsets from their original datasets. The experiments comprise 2 parts. In the first part, we validated the face verification performance of the proposed PAE. In the second part, we conducted an ablation study on other modules and validated the face reenactment performance of the entire PASL model. The table and precision recall curves show the face verification performance compared with state-of-the-art encoders on 6 pose pair subsets of MS1M. The PAE outperforms other encoders. In the ablation study, we evaluated the quantitative and qualitative performance with and without the cycle consistency loss considered in the shape generator CSG, and with and without the attention mechanism in the face generator AEG. These results verified the contributions of the cycle consistency and attention mechanism. We compared our approach with state-of-the-art methods for handling self- and cross-ID reenactment on the common Vox Celeb 1 dataset and the MPIE-LP and Vox Celeb 2 LP datasets designed to evaluate large pose reenactment. The proposed approach performed the best in all metrics and on all datasets. Here are a few samples of self-reenactment for qualitative comparison. Our PASL demonstrates better identity preservation and action transformation. This slide shows samples of cross-ID reenactment. Again, the PASL shows better identity preservation and action transformation. Please visit our GitHub for the PASL model and more.